ladies and gentlemen. My name is Abdurrahman Ali, and today, inshallah, I will try to solve question number 1 in mechanic of materials. So, let's see the question. An axial force of 200 kilonewton is applied to the assembly shown by means of rigid end plates. Determine the normal stress on the aluminum shell, the corresponding deformation of the assembly. So first of all, guys, this one is statistically undetermined. What does it mean? It means that you cannot solve it directly. You have to manipulate the equations in order to establish or to find the answer. So first of all, we have to put all the given things. So we have the force, or the axial force, which is 200 kilonewton. And he wants the normal stress on the aluminum shell, and he wants the corresponding deformation. Deformation is when you apply some force on this metal, the length is going to change because it is compression, so it will reduce, which we call it by delta. So now let's start solving this issue. So we are having two main equations. First equation is, P, or let's make it F. F, it's better. Total force equal the force of aluminum plus the force of brass. He already gave us the F total, which is 200 kilonewton. And we don't know force for the aluminum, and we don't know for brass. But now from this one, we can know, or let's draw something like that. This is the aluminum, and this one is the brass. And we know there's an axial force of 200 kilonewton. And the second important equation, it is total, or delta total, is equal to AL plus BR, the brass. So now this one is going to be force for AL multiplied by the length for the aluminum and the area of aluminum multiplied by the E of aluminum equal, which is this one, force of brass multiplied by the length of brass and the area of brass multiplied by E of brass. So now let's write our First, we have to find the FAL, which is the force in the aluminum, and the force in the brass. We don't know them, but we do have the length, and we need to get the area, and this one is given already in the equation, or in the, you can see it is for brass is E is 105 gigapascal, and aluminum E is 70 gigapascal. So let's find now. We know the length of AL is the same for the length of VR, which is 300 millimeter. So you can say that it's equal to 0.3 meter, or you can say 300 times 10 to the power minus 3 meter. Both are the same. So put it in circle or square it. Now we find L for aluminum and for brass. Now let's find the area for aluminum and for brass. So area for aluminum is equal to, we know the area equation is pi d square over 4. So pi, we know the diameter. Now for aluminum, you know the diameter here, you can see the diameter for aluminum is 60, and the for brass is 25. So in order to get the area for that one, we need to subtract 60 or 25 from 60. So it is 60 minus 25 for the whole square over 4. So area for aluminum is gonna be 2335.4 millimeter square. Now for same thing for also for the brass, we will do the same here. We're gonna get 490.63 millimeter square. Okay. Now, after we found the area for aluminum and area of brass, so let's go to our main equation, which is this one. And substitute the numbers here. So we're gonna get like this. Force of aluminum, we don't know it yet. Multiply by 0.3 equal, you know, the force for brass multiplied by 0, because this is L, this is L. And now for the area, we know the area here is 2335 times, because it's in millimeter square, we need to multiply it by minus to the power 6, or times 10 to the power minus 6. And the E for this one is 70 times 10 to the power 9, because it's in gigapascal. And we know the area for the brass is 490 times 10 to the power minus 6. And we know the E for this one, for the brass, is 10 105 gigapascal, so it's 10 to the power minus 5. So after a little bit calculation, we know that here is equal to 1.835 times 10 to the power minus 9 FAL equal to 1.16 times 10 to the power minus 3 minus 5.82 times 10 to the power minus 9 fourths of AL. Okay, then we can substitute that one in the equation itself. So after a little bit also mathematics, we can get the FL FAL is equal to 151,534.9 Newton. Okay, after we found this one, we can go back to our original or our first equation, which is this one, F total. We know it's 200. We know FAL is the new number that we got it, and plus FBR to find the force on the FBR. So F total equal FA plus FB. So FB equal FT minus FA, FT minus FA. Sorry guys, we don't need actually to find the FB because we need the sigma. So we can go and solve directly, like sigma AL equal, the force of AL over the area of AL. And we know we put the numbers here, which is 151534. So because I took a long time for this one, we know the forces, we already got it, which is here, this one, and we know the area of AL. So just substitute and you will get this number, 64.8 megapascal. And for the second thing, we need the total or the total delta, okay, the change in length. So you can put these numbers, okay, 151,434.9 times 0.3 over 2335.4 times 10 to the power minus 6, okay, times 70 times 10 to the power 9. So you will get 2.78 times 10 to the power minus 4 meter. That's the total, change in length after the compression or the axial force. Thank you guys for watching. I hope you enjoy this one, and see you next time.